let's continue to find absolute extrema. So we have a new function. Remember, first we need to look at continuity to see if it even guarantees one. So is this function continuous on this interval? So if you remember, x to the 2/3 looks something like that. So it's not differentiable because it has that sharp turn. It is continuous though. So I can take this and say, yes, f is continuous on -1, 3. So I know that I should have an absolute max and an absolute min. So I need to find my critical numbers first. So this is where f prime of x equals 0 or undefined. So let's find f prime of x first. So bring the 2/3 in front, and the 3's will cancel. We should be 2x, and then 2/3 minus 1 to the -1/3, and then minus 2. And I'm going to rewrite this a little bit. I'm going to bring that x down, turn it into a cube root. So it looks like that. That just helps my brain a little bit better. So let's find our critical numbers. First off, where f prime of x equals 0. So I have 2 over the cube root of x minus 2 equals 0. So let's solve this out. Multiply by the cube root of x to get it out of the denominator, because things in the denominator are gross. Let's bring this up so we get divide by 2. So I have 1 equals the cube root of x. So at this point I'm going to cube it to get rid of that. So x equals 1 cubed, or 1. So that's our first critical number. But we also need to find where f prime of x is undefined. So if I look at this, where is that going to be undefined? Well, it's going to be when the denominator equals 0. And if x equals 0, the whole denominator will be 0. So those are my two critical numbers. So step 2, let's test our critical numbers and our endpoints. So I have f of -1, f of 0, f of 1, and f of 3. So I'm going to pause the video. I want you guys to try plugging all of these in. Remember that we're plugging it into f, not f prime, and it might be a little helpful to rewrite it like that. So we change our 2/3 back into a root. So rewrite it like that, solve all of these, and then let's see if we can find out where our absolute max and min are. Welcome back. Those are the answers you should have gotten, and so our absolute max is 5 and our absolute min is 0. Okay, number 10. I want you to try this one out all on your own, because that's where we're trying to head, right? So we'll do the continuous part together. So continuous, this is a sine and cosine, which is waves, so it's always continuous. So f is continuous on 0 to 2 pi. We're good. So step 1, find your critical numbers. Step 2, test your critical numbers and your endpoints. And then step 3, write your final answers. So try this one on your own, and then come back and see how you did. Welcome back. Let's see how you did on your critical numbers step. So this one, we wanted to know where g prime of x equals 0. So first off, let's check your g prime and see if you got that right. You needed to do chain rule on the second part because it was 2x, so we need to times by 2. So we should have gotten 2 cosine of x plus 2 sine of 2x at the end. Now we want to do where it equals 0, so I set all this equal to 0. Now this part, if you got stuck here, don't worry, I did too. So this right here is called the double angle theorem. You can Google it if you want. I totally forgot about it. I had to look it back up. The double angle theorem says that sine of 2x equals 2 sine of x cosine x. So that's one that I had to relook up. You should probably have it in your hat. That's one that comes up occasionally. Not as much as your like sine squared plus cosine squared equals 1, but it does come up. So I changed that. So then I got 2 cosine of x plus 4 sine cosine. Then I factored a 2 cosine out. So then I was left with 1 plus 2 sine equals 0. And then set them both equal to 0. So I have cosine of x equals 0, which cosine of x equals 0 at pi halves and 3 pi halves. That's where your x value is 0. Also, I know last time we would have only said pi halves, but look at this. Your interval is from 0 to pi. So you'll want all the answers in the unit circle from 0 to 2 pi. Then I solve this one, get sine of x equals negative 1/2. The y value equals negative 1/2 on the unit circle at 7 pi 6 and 11 pi 6. So those are your critical numbers, and there's nowhere where it's undefined, so we're good there. So then the next step is to test all our critical numbers and our endpoints. So g of 0, g of, let's see what's next, pi halves, g of 3 pi halves, g of 7 pi 6, g of 11 pi 6, and g of 2 pi. Phew. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. There we go. So you're going to test all of these by plugging them in to our G. And you're welcome to use a calculator for this part. So I'm going to pause the video, have you solve all of those, and then we'll see what our answers are. Welcome back. When you plug all those in, those are the answers you should get. If you didn't, you might want to double check that you're in radians, not degrees. We're plugging in radians. We need to be in radians. And so then we can look at this. Our global max is 3, and our global min is negative 1.5. So that's all for our max and min problems. In the next video, we're going to be talking about the mean value theorem, which is a really important theorem and is usually on the AP Calc test somewhere.